I welcome you all in this lecture on parameter estimation examples, which is a sub module for the course modeling and simulation of dynamic systems. Last lecture we have seen that when we derive the mathematical model, we may have some parameters in that model whose values we do not know. Okay. So, the aim of the parameter estimation model is to find out those values, because if you want to simulate those mathematical expressions, you need to know those values. Okay. So, last lecture we have seen the ways of finding out of these parameters or estimation of parameters, and we have seen the least square method. Basically, these parameters are estimated with the help of the input and experimental data, which we get by giving a certain input and observing the output. Okay. And these input and output values are fed to our model. Okay. And then from that model we try to estimate the parameters. So, this we have seen in the last class. Now, in this class we will be taking up two examples to illustrate you how these parameters are estimated. So, the first example is the least square estimate of two parameters. So, suppose I am given a model, a simple model. First example, we are taking a very simple example, say z is equal to cx plus d. Suppose this model is given where the parameters c and d will be estimated. We are interested in finding out, estimating the parameter of this c and d. Okay. And for given three sets of corresponding values of z and x. Okay. So, suppose I am given these values, say z is equal to 0.8 is equal to say c into 1 plus d. So, this is my one expression which is given to me. The other one is say 3.0 is equal to c into 2 plus d, and another expression is say 4.0 is equal to c into 3 plus d. So, these three equations are known to me, and these expressions I do not know, as I said, the values of c's and d's. So, these values of c and d are to be estimated. So, here what we do is that first we write these three equations in the standard form which we have defined in the previous lecture. Okay. So, here first I write the y vector as say 0.8, 3.0, 4.0. So, this is my y vector, and then we had a phi matrix, and that phi matrix, and then we had the last column vector as the unknown vector. Okay. So, in this case our c and d are unknown. So, I am writing this c and d unknown vector here, and the first expression, these elements of the matrix I can find out by looking at these expressions. So, the first one will be 1 1, okay, and the second one will be 2 1, and the third one will be 3 1. Okay. So, this way we can find out. So, this value is actually my y value, and this value is actually my phi value. Okay. And this value is basically my theta value, as I am talking to you with respect to the least square method, which we have seen in our previous lecture. Okay. Now, as you remember last lecture, we represented these rows in a short form, and so I am just writing them as say phi 1, phi 2, phi 3. So, these are basically the 3 rows, and then we had the unknown vector, column vector here, that is the CD. So, this is basically my theta, and this is my the same phi. Okay. So, this way I have represented it. Now, the least square value, the relation for the least square value which we have seen. So, the theta least square, this value was our phi transpose phi inverse, okay, into phi transpose and y. Okay. So, this is what we had. So, I can write, this is our phi value. So, I can write the phi transpose here. Okay. So, what will be phi transpose for this? It will be 1 1, it will be 2 1, and then this will be 3 1. So, this is my phi transpose which I have written here. Okay. So, this is my phi transpose, then we have the phi. So, phi I can reproduce this as it is. So, this is my 1 1, 2 1 and 3 1, and we need to take we need to multiply this, and then we need to take inverse of it. Okay. So, this is what we have to do, and then again we have the phi transpose. So, it will be basically the same thing which will be coming here. Okay. So, I can just write it as 1 2 3 and 1 1 1. So, this is my this parameter here, and then y we have this vector I have already written. So, this vector I can write as 0.8, 3.0 and 4.0. Okay. So, this way I complete this one. Alright. Now, what we can do is that we can multiply these two matrices, okay, and whatever result comes, I take the inverse of it, okay, and then I multiply these two matrices again, and whatever is there that is multiplied with this column vector. Okay. So, this when we do that, so this is what we get. Okay. So, the value which we are expected to get, that is 1.6 and minus 0.6. I am not doing those calculation for you, please just it is a simple multiplication and inverse, so that you can work out. And what I was telling you, that this theta ls is actually our unknown values, okay, in which we are interested in. Alright. So, we are trying to estimate these theta values, okay, and what is this theta? This theta is basically C and D values. So, whatever we have got here, this is nothing but our C least square, and this is D least square. Okay. So, this is what we get, and so the C least square value will be 1.6 and D least square value will be minus 0.6. Okay. So, this is how we can estimate these values of C and D. Okay. So, our general expression could be, or after estimation of these parameters, could be Z is equal to 1.6x plus plus into minus 0.6, or we can say that 1.6x minus 0.6. So, this is what is going to be our expression, and using these three results and the least square method of estimation of the parameters, we could identify these unknown parameters C and D. Okay. So, this is one example, and another example which I want to take is this one, where we would like to estimate the KV. Okay. So, that we can do. So, first let us try to understand the problem, and then we will try to estimate the parameter. Okay. So, you can look at this figure, it is basically wall. Okay. So, in this example we want to estimate the wall parameter. We do not know the wall parameter, and we are interested in finding out the value of the valve parameter. Okay. Now, in this valve you can see that this is the direction of flow, say a pipe, okay, through which a flow Q takes place, and here is a valve. Alright. Now, in this valve there is a control signal U coming here, okay, and because of this control signal there is, say when the say water passes through this valve, okay, there is a drop in pressure P. Okay. So, we assume that the flow Q is given by this mathematical model. Okay. So, the mathematical model is Q is equal to KV, okay, and U underscore P. Now, you see that here this KV is unknown to us. We are not aware about the value of this KV. Okay. So, here as I was telling you, U is our control signal and P is the pressure drop. Our aim is to estimate the wall parameter KV from M corresponding values of Q, U and P. Okay. So, I know I have M corresponding values of this Q, M corresponding values of, say, this U, and also M corresponding values of these P's. So, these are known to me, and I am interested in finding out that what is my value of this KV. Okay. So, this is my problem, okay, problem statement for this example, that I am interested in finding out the KV. It is a very real practical problem, okay, to find these wall parameters which are usually unknown, and they are determined by this way only, the way which I am just going to explain to you. Okay. Fine. So, we start by writing the model on the regression model of the form y is equal to phi theta. So, you remember we had the model y is equal to phi theta, and remember in this y is equal to phi theta we assume that we know the value of y, we know the value of phi, and we wanted to find out this value of theta. Okay. So, in this expression, the expression which we have, we identify what is our y, what is our phi, and what is our theta. Okay. So, first we need to find out those, identify those parameters. Okay. So, here basically I can write this Q as U underscore under root P into kV. Okay. Now you see this k, we are interested in finding out this kV value. So I write this as theta and u underscore p, these both are known to me and they are on the right hand side. So I just write them as phi and this q I am writing it as y. Okay. So this is how I am doing it. So we have here y, we have here phi and we have here theta. Okay. So as I said, we we can assume that I know m such values. Okay. I know m such values. So I can write these expressions for each value and up to m such values. Okay. So what will be my expression? My expression will be basically here q1, q2, qm. We know these m values. Okay. And here these will be basically say u1 and root p1. Okay. Likewise I can write u2 root p2 and um root pm. Okay. So this is my phi and then of course I have got the kV. Okay. So this is my, as I was telling you, this is my y and this is my phi and this is my theta. Okay. And our interest here is to find out this value of kV. So here what we have done is that first we are writing this mathematical expression which has been given to us in the regression model form. Okay. Then the least square estimate of kV, that is kV least square, can be calculated using whatever the standard value which we have evaluated. The unknown value least square as we have evaluated, that was phi transpose phi whole inverse. Okay. Into it was phi transpose y. Okay. So we can substitute these expressions here and then we can get the theta least square. Okay. So what values are here basically? So this, if I take the phi transpose here, then this will be basically like this, that is under root u1 under root p1, okay, and u2 under root p2 and so on, um under root pm. So this is my first term here. Okay. So this is my first term. Then what I have is phi. So phi will be as it is. So that is u1 root p1, u2 root p2, and then we will have root pm. So this is there, and then whole to the power minus 1 here, inverse, into what we have is again this transpose. So I can again write that u1 root p1, u2 root p2 and root pm. So it is this value and then the y value. Okay. So and y value as you can see here, it is these q's. So I know that. Okay. So these things are known to me. So q1, q2 and qm. Okay. So this is what? This is basically theta ls, theta least square. And what is that theta least square? That is basically the kV least square. So, this is nothing but this is kV least square. Okay. So, what we can do is now we can simplify this expression in order to estimate the value of this kVLS. Okay. So, this kVLS that is kV least square can be written as, now you see when you are going to multiply this with this one, okay, what you will be having actually is U1 root P1 square plus, okay, we will be having U2 root P2 square plus we will be having root Pm square. So, this is what we are going to get, okay, and to the power minus 1 here, since it is a scalar it will be minus 1, and then of course we will be having these components, that is U1 Q1 root P1 plus U2 Q2 root P2, okay, plus QM root Pm. Okay. So, basically this is what we are going to get. So, this is actually what we have, this is actually there are one row and m column, okay, here, and here we have m rows and one column. So, when we do the multiplication here, I will be getting one row one column only, that is why I am getting it here like this. Okay. So, this one I can write kVLS as U1 Q1 root P1 plus U2 Q2 root P2, okay, plus QM root Pm divided by, of course, I can just take this to the denominator. Okay. So, this is what I will have, U1 root P1 square plus U2 root P2 square, okay, plus root Pm square. Okay. So, this is what we are going to get, and this way I can estimate this value of kVLS, which is unknown for us in this case, alright. And once we have this value of kVLS, okay, I can write the expression for my Q, say Q is equal to kVLS U under root P. So, this way I am able to estimate this value of kVLS, and this value is now known to me, which was unknown earlier. Okay. Now, but here you see that for this estimation I need all these values, okay, that is I need the values of say all the inputs, that is U1, U2, Um, I need the pressure drops for all the M cases P1, P2, Pm, and not only this, I need these M set of these Q values also. So, Q1, Q2 and Qm. So, these things I need to know, then I can estimate this value of the unknown parameter kVLS. Okay. So, this with this I will conclude this lecture. Thank you for your attention.